Hey everyone, I'm so glad you're joining us today for this explainer. We've got something really fun planned. We are going on a physics parp adventure. Now you might be thinking, what even is physics? Well, it's basically the science of the invisible rules that control how absolutely everything around us moves. From the way you jump up and down to how a swing flies through the air, it's all physics. And today, we're going to uncover these hidden rules together. But right off the bat, I've got some big questions for you. Have you ever wondered why a rolling ball eventually just slows down and stops? Or think about this, why is it super easy to push a tiny toy car, but it's basically impossible to push a real giant truck? Well, the answers to these mysteries are actually hiding right outside. So let's pretend we're stepping right out of the classroom and heading to the park to figure out how these invisible forces actually work.
All right, let's get into it. Imagine you're standing at the edge of this massive, bright green park. You've got a bright red bouncy ball right at your feet. You take a few steps back, run up, and you just give that ball a massive kick. You watch it zooming away across the grass. But what happens next? Does it roll forever and ever? No way, right? Eventually, it slows down and comes to a complete stop. But why?
Well, that brings us to our very first big rule of physics. It's called the first law, but honestly, I like to call it the lazy rule. The fancy science word for this is inertia. And inertia just means that objects resist changes to their motion. Basically, things are kind of lazy. If an object is resting, it wants to stay resting. If it's moving, it wants to keep moving at that exact same speed, forever. That rolling ball, it totally wants to keep rolling. But the grass acts like this invisible hand, rubbing against the ball and pulling it to a stop. If you kick that same ball in outer space where there's no grass, it would literally just keep going and going.
Now, think about a heavy book resting peacefully on a table. This shows us the totally opposite side of the lazy rule. That book has inertia too. Because it's sitting still, it just wants to stay sitting still. It's not going to magically decide to jump off the table all by itself, right? It's going to stay right there until an outside force, like your hand, pushes it. It resists change. So the big takeaway here is that things really just like to keep doing whatever they're already doing. Now it's your turn. Teachers, go ahead and pause the explainer right here. Class, can you think of another example of inertia or the lazy rule? What else sits perfectly still until you push it? Shout out your answers!
Welcome back. I bet those were some awesome examples. So let's see how this builds into our next big invisible rule, the second law. I call this one the heavy versus light rule. It's all about three words: force, mass, and acceleration. And acceleration just means speeding up. This rule tells us two things. First, if you push something with more force, it speeds up faster. Second, if something has more mass, meaning it's heavier, it's going to speed up a lot less than a lighter object, even if you push them both exactly as hard. Picture someone pedaling a bicycle across a park path. When you first get on, the bike's just sitting there. To make it accelerate, you have to use force. You push down on the pedals with your feet. If you push gently, you move slowly. But if you stand up and push those pedals as hard as you can with a ton of force, you're going to zoom down the path. So more force means more acceleration. But what about mass? How heavy something is. Let's compare two totally different things. Imagine pushing a tiny, light toy car across the floor with just your finger. Super easy, right? It just zooms away. Now, imagine trying to push a giant, real-life truck with your bare hands. Even if you use all your strength and push with a massive amount of force, that truck is barely going to budge. Because it has so much mass, it really resists speeding up. Heavy things are just way harder to move than light things. So the point here is that motion changes depending on how hard you push and how heavy the object is. Time for another quick break. Teachers, hit pause again. Class, can you think of another example of a heavy thing and a light thing being pushed? Maybe think about throwing a light tennis ball versus trying to throw a super heavy bowling ball. Shout out your ideas.
Awesome thinking, everyone. Okay, let's dive into our final invisible rule of the day. The third law, or my personal favorite name for it, the pushback rule. This rule states that for every single action, there is an equal and opposite reaction. What does that actually mean? Well, it means forces always, and I mean always, happen in pairs. You can never have just one push. Whenever you push something, that thing pushes you right back with the exact same amount of strength.
You actually see this pushback rule in action every single day. Just by walking. Let's break down the invisible forces of walking on grass. Step 1. When you take a step, your foot actually pushes backward on the grass. That's the action. Step 2. Because forces always come in pairs, the grass does a reaction. The grass pushes your foot forward with the exact same amount of force. So your push backward makes the ground push you forward, and that is literally how you move.
We can apply this exact same rule to a playground swing. Think about when you're on a swing trying to go higher and higher. Step 1, you lean back and pump your legs out, pushing forward into the air. Step 2, that action causes a reaction. As you push forward, the invisible forces push back against the swing, sending you flying high up into the air. You're literally pushing and pulling against the world to fly.
So just remember, you can't push something without it pushing you back. Time for our final break. Teachers, pause the explainer one last time. Where else do you see an action and a reaction happening? Here's a huge hint for you. Think about a giant rocket ship blasting off from a launch pad. Go ahead and shout out your best ideas.
I am so incredibly impressed with you all today. Let's do a quick wrap-up of our 3 laws. First, we've got the first law, the lazy rule. Things resist change, so motion stays exactly the same until a force interrupts it. Second, the force and speed rule. Force causes acceleration, but heavier things need a lot more force. And third, the pushback rule. Action equals reaction, which means forces always happen in pairs.
You know, you are all officially physics experts now. But the learning doesn't have to stop here. I have a really fun classroom challenge for you. With your teacher's permission, I want you to try pushing items with different weights around your classroom. Try pushing a light pencil across your desk. Then, try pushing a heavy, full backpack. Really feel the difference in the mass and notice how much force you need to use. See if you can actually feel that second law right in your own hands.
Okay, before we say goodbye, let's do a quick fun quiz to test those super smart brains. Shout out the answers as loud as you can. Question 1. Which law is the lazy rule that explains why a rolling ball wants to keep rolling, or why a resting book wants to stay resting? Is it the first, second, or third law?
That's right. It's the first law, inertia. Okay, moving right along to question 2. Think back to the heavy versus light rule. Which object is harder to push and make it speed up? A tiny, light toy car or a big, giant, super heavy truck?
Exactly. The giant truck is way harder to push because it has more mass. Incredible job. Okay, our final question. Question 3. Think about the pushback rule. When you push the ground backward with your foot to walk, what does the ground do to you? Yes, it pushes you forward. You guys are absolutely brilliant. I hope you had so much fun on our Physics Park adventure today. Just remember, these invisible rules of physics are literally everywhere around you, in everything you do. So what invisible forces are you going to spot on your way home today? Keep exploring, keep asking questions, and I'll see you next time.